The reason we exist is because you cannot stay ahead of all threats. So
and what you're on it, we will be going work that you're on it, we will be going work that we can do as well as person literature is concerned. This is 44 page static, first few pages, and you can always go to this study guide to hydraulic system, whether it is liquid that is in their equal size. So it is forced down. So it is forced down. Is oil. If the other side is oil. If the other side is placed of the container. Side is placed of the container. A force to amount. A force to amount of force. Diagram. And then area is 1 inches. And load into 1 feet. Piston bends to move 1. The bigger the piston or cylinder, this is the principle that allows amount of force on the handle. Illustration: 10 inches with a 10 square inch advantage in hydraulics can be. We have another diagram. We have the lift. Although hydraulic transmissions, many of the components is similar to on pistons. Many of the components is similar to on pistons. Will be the all amount or the rate which of our hold the fluid system that will be the to reservoir. This particular zone is in chain. The increased oil flow to right shows a gear sets gear pump oil. The fluid is the dish pump oil. The fluid is the dish to the together in the oil. So this is an example of the control valve. All right. So what we're going to do is we're going to come back to this article later on today. But for right now, let's go ahead and take a look at a few of the videos. Let's go ahead and take a look at a few of the videos that's going to be animating.
Remote monitoring and management, remote access, help desk and ticketing, smart automations, patching,
Hello everyone, this is Ms. Pneumatic here. Today's topic is a hydraulic system. We're going to learn about what the hydraulic system is. We're going to learn about what the hydraulic system is, the key components and operating system. It is a system that uses fluid energy made by compressing hydraulic oil to generate power and control machines and devices, such as a hydraulic cylinder and hydraulic motor. It is characterized by the use of pressurized application method hydraulic systems, precisely as well, largely be divided into comprises in oil is capped, and removes air bubbles and the device a oil using the hydraulic controller. From the hydraulic generator is valve and flow control valve. The flow control valve regulates the flow rate supplied to the actuator to adjust the operating speed of the actuator. Last but not least, let's see the hydraulic drive unit. The hydraulic drive unit converts the fluid energy into mechanical energy. This section is where the actual operation takes place through the high-pressure oil. A hydraulic cylinder and a hydraulic motor can be found here as a driving device. Among them, the hydraulic cylinder, which is most commonly used, carries out various tasks such as pushing, pulling, and moving objects through a linear and reciprocating motion. So far, we've looked over the components of the hydraulic system one by one. Other than the main devices, there are peripheral devices, such as filters that remove impurities from working fluids, and manometers for pressure measurement. Moving on, let's now find out how these devices work sequentially. First, the hydraulic pump soaks up the hydraulic oil inside the oil tank. At this point, an electric motor connected to the hydraulic pump continuously transmits mechanical energy to the pump through reciprocating motions. This is what causes the internal gears of the hydraulic pump to perform rotational motions, producing high-pressure oil. This is where mechanical energy turns into fluid energy. Then, the high-pressure oil moves to the pressure directional control valve. The pressurized oil controlled this way flows through the flow control valve into the actuator, activating the actuator. Various tasks will be performed depending on the functions of the actuator through reciprocating linear motion, hydraulic cylinder, or through rotational motion, hydraulic motor. This is where the fluid energy is converted back to the mechanical energy. The hydraulic oil that has been complete with the process will return to the oil tank through the valve. Then, the hydraulic oil in the oil tank is being soaked back up to the hydraulic pump to become high-pressure oil. These processes are repeated to allow the actuator to operate repeatedly. This is how we can generate and control large mechanical energy with only a small amount of force through the system process using hydraulic oil. Let's start with the advantages. First, it converts a small force into a larger force. Second, automatic and remote control is available. Remote control prevents machine operators from being exposed. Third, it is easy to control speed, force, and direction. This is because the oil circulates to automatically perform lubrication and anti-corrosive actions on the system devices, thereby effectively reducing wear and corrosion problems. Fifth, stable and precise control can be achieved. As liquid is used as working fluid, it is less compressible than the pneumatic system that uses gas as working fluid. Less compressibility also decreases fluid pressure variability, ensuring more precise control. Disadvantages of the hydraulic system are as follows. First, it is vulnerable to temperature changes. Viscosity decreased due to temperature changes may affect unit operation. Third, there is a risk of ignition. The working fluid is oil in the first place, so operators must take caution and prevent the oil from being ignited. Oil circulation may form small bubbles, and failure to remove such bubbles properly may result in poor operation of the actuator. Lastly, let's talk about how the hydraulic system can be applied. The hydraulic system is precise control is available. Typically, it is used when the linear motion or rotational motion of a machine or a greater force is necessary. As I mentioned earlier, it is applicable to all types of industrial environments, from construction and transportation systems such as excavators, trucks, cranes, bulldozers, special purpose vehicles, and lifts. Machine tools such as CNC lathe, milling machine, drilling machine, transfer machine, and grinding machine, steel and metal machinery, such as forging, casting, and cutting, and robotics, such as robots, rockets, and a whole lot more. Today, we took a closer look at the hydraulic system.
All right, so if you notice, there are more applications for the hydraulic system than just vehicles. Right now, we are focused on simply the vehicles, but at the same time, if you wanted to venture out to something else, you can if you have the knowledge on how hydraulic systems work.
Fluids are different, making it slightly vary in terms of the characteristics, applications, and devices. If you would like to learn more about the difference between the pneumatic system and the hydraulic system, click on the top 6 differences between the pneumatic system, and I'll see you in the next video. Bye!
Yeah, we have a couple shorts. We're going to be looking at a few shorts that's going to explain it, animations and things that make most of
Very basic hydraulic system. Connection from the manifold is being used in the system. Okay, so I'm going to go ahead and there's equal everywhere or to the pressure line. Right now, pressure is coming from going up here, holding this back out. When I activate it, my pressure and then the oil that's over here that's trapped here leaks back the tank. You can see that the cylinder extended out and it retracts. So when I press my lever here, my oil that's coming from my is being connected back to tank, and this oil with a full.
Have you ever seen a tennis ball get completely squeezed? Possible by the power of liquids, also known about water? Is it ocean or raindrops rippling a pond? Or is it something a little more extreme? Yeah, this is definitely not the first thing that came to my mind. But when pressure is applied, like with these jets, other liquids like it, is in hydraulic. Liquid so powerful is how the syringe is filled with air. Now if I still push the plunger down, pressed, because when I let go of the plunger, if I block the end with my fingers, easily compress. Instead, all that pressure comes rushing out. Oops, who is Pascal, you may ask? Well, what didn't Blaise Pascal do? Equally throughout the fluid. So, like this. This is basically are like giant syringes. If you push the machine right, you can engines are used to lift cars, building material called the other types. Even some, now that you know a little more about machines like this claw. And if you're
thinking about it, meat.
And if you're
thinking about it, meat.
With the like is going to have to the minimum. With the like is going to have to the minimum and the maximum of whatever you need. Because think about what we're talking about. Going to then the brakes that you have, the brakes.
The brake pedal. The master cylinder. The brake pedal transfers the mechanical force applied by the driver to the pushrod through the servo to the master, applying additional force to the braking system. When braking, pistons with seals and system. Brake fluid with efficient brake fluid to stop air lines, which carry the brake fluid to the front in action. Pressure. Entire hydraulic system and forces brake fluid. The hydraulic pressure on the seals in the caliper cylinder pistons, which in turn create the basics of
w1d4s2 IQ.
The pressure relay